Hello everyone and welcome to the project demonstration for my level 6 production project, Intelligent Hybrid Book Recommendation System using NLP and user preferences. I'm AsmitGhimire and now I'm going to begin my presentation. With thousands of books published every year, it is often faced information overload. Traditional recommendation systems rely either solely on content similarity, which can create filter bubbles, or purely on user ratings, which suffers severely from cold start problems when a new user joins with no historical ratings. To solve this, I designed and built a productive hybrid recommendation system leveraging the benchmark Goodreads 10K dataset. By combining natural language processing for semantic book content analysis with collaborative interaction filtering, the system delivers personalized, highly accurate and diverse book recommendation in real time. So, starting with dataset ingestion and processing. Let's first look at the dataset in data ingestion foundation. Our system is built on benchmark Good Books 10K dataset, as you can see over here, which contains metadata for 10,000 unique books, 6 million historical user ratings across 53,000 users, and nearly 940,000 to read with these interactions. To enrich the dataset beyond raw titles and authors, I developed an enrichment script using Open Libraries API to pull full book plot description and tag mappings. One crucial challenge with Goodreads data is tag noise, like to read, owned, or favorite provide zero semantic information about book content. In our processing script, which is cdata.py, we filter our administration noise tags, which you can see over here, isolating the true genre tags like fantasy, sci-fi, thriller, and historical fiction. All this data is ingested into a SQLite database with index tables for fast querying of books, ratings, wishes, records, user preferences, and pre-computed similarity matrix lookup. As you can see over here is my SQL tables. It contains all the tables from my database. Book tags, and all that, user preferences. And these are my data sets. Moving on to architecture recommendation and engine deep dive. Now let's examine the heart of the system, the recommendation engine. First, we have content-based filtering. The module implemented in npl-engine.py. We constructed a structural representation for each book by concatenating its titles, authors, genre, and description. Using TF-IT vectorizer function, we transform these descriptions into sparse TF-IDF feature matrix using unigrams and bigrams. We then calculate pairwise cosine similarity across all 10,000 books. And to ensure sub 50 ms API response in production, top similarity scores are pre-computed and cached in SQLite, routing expensive matrix calculations on every web request. Moving on to the hybrid recommender. as users interact with the app, rating books 1 to 5 stars or adding them to their to-read wish list, the system dynamically builds their real-time preference profile vector, and the final recommendation score combines content similarity and user interaction preferences using a weighted hybrid formula, which you can see over here. And I have also implemented a cold start fallback. So if any new users registers with no ratings, no history, the system then handles this cold start problem using the onboard genre selector during registration. If 0 interactions exist, it seamlessly fallbacks to the popularity weighted baseline calculated from Goodreads rating counts and average scores. Now after that, I'll move on to the website, which I've already run over here, and now I'll register a new user. Yes, test 1. Oh, sorry, that image is already registered. And here you go. The onboarding genre selection screen pops up, and for new users, you can select which genre you like, or you like to receive recommendations at first. And this will tackle our cold start problems for new users. And I'll now select to genre over here, and then there we go. Now in our home screen we have personalized recommendation according to that genre selection over here, as you can see. And each book shows the book cover, titles, author, and all that, top genre, badge. And now for the real-time filtering, I'll search a book over here, Harry Potter. As you can see, the application features real-time search across 10,000 books by title, author, or genre with instantly bounced API filtering. And if I click on the book over here, it will show all the details that I can interact with and I can see. So these details are enriched by Open Library. The descriptions are pulled from there, and I also have ratings and wish list and other interactive controls over here, and you can also see similar books over here by NPL cosine distance. So I will now add this to my wish list and also give it 5 stars. When I rate this book 5 stars, the backend immediately updates the user interaction profile, and notice that the recommendation tabs is now changed to match my preference according to my wishlist and ratings. And it also comes with an explanation of why I was recommended this. As you can see, matches your preferred genre, fantasy, sci-fi, and all that. And I can view my wishlist over here, as you can see, and I can also view my rated books over here. And I also have preferences which you can update, but I'll skip for now. And you can also select different genres that you would like to filter, and also have content weight, through which you can filter ratio between the content and the collaborative filtering. As you can see, if I change the content weight to that and change the recommendation system, the recommendation weight gets changed. You also have the option to add the books to the wishlist from directly by clicking over here. And you can also browse the books, the categories, browsing all 10,000 books over here, as you can see. Yeah, there it is. The catalog, and it also shows my rated and wishlisted books directly on the home page. Now moving on, system evaluation. To rigorously validate our recommendation system, I built an offline evaluation framework in evaluation.py, as you can see over here. Here it is. And we evaluated our models on just a test split of 6 million ratings across users with at least 10 hit historical ratings using focal recommendation metrics, precision at K, recall at K, hit rate at K, and NDCZ, normalized discounted cumulative gain. And the key findings were that pure content-based filtering achieves a strong precision for new users with narrow genre preferences, but lacked serendipity. Pure collaborative filtering excelled in recall for active users, but failed completely across to users. But our hybrid model achieved the highest overall performance, proving that the combining NLP content signals with user ratings yields superior recommendation quality. As you can see over here, I have run the evaluation, and you can see all the values over here, precision, recall, and all of that. And also furthermore, by pre-computing top TF-IDF similarity pairs in SQLite, average recommendation on query latency remains under 35 milliseconds. Under 35 milliseconds, you can see over here, and which easily meets our real-time performance requirements. And that is it for my evaluation part. And for the conclusion, to summarize, I have successfully implemented an end-to-end intelligent hybrid book recommendation system using Flask, SQLite, Vanilla.js, and I have solved the data noise using custom NLP tag filtering and English book description via Open Library. I have addressed the cold start challenges through genre selection, proprietary fallback, and I have also empirically verified model performance using standard evaluation metrics on 6 million ratings. And that is it, and thank you.